Matt Sisk is an archaeologist using geographic information systems to address questions related to the origin and character of modern human behavior. Most of his work is focused on landscape analysis and excavation methodology in the Paleolithic area of southwest France, where he serves as the associate director of the Abri Castanet project. And so he's also a fine fellow, and we're happy to introduce him. I think you're mic'd, so I'm going to put this out of the way.
Yeah, I should be. Everybody hear me? Yeah. Okay. Okay, just make sure everything's working here. And it's not. There. Okay, so we've heard several people talk about real generating 3D images from Gigapans with stereo pairs and various things like that. But what I'm going to be talking about today is using the images with another source of three-dimensional data. So essentially kind of draping imagery over top of 3D data. And I'm going to kind of divide it up into two sections. One dealing with an interpolated surface for an archaeological level, and then one merging the images with 3D scan data. So to start with, my first example, and most of what I'm going to be talking about comes from southwestern France. So as you can see from my title slide, it's a pretty harsh place to work. Difficult field conditions. Oh, great. Is that better? Okay. So I'm going to talk a little bit about using the Gigapixel imagery with pre-generated topographic surfaces, particularly from the site of Abri Castanet in southwestern France. And just as a very brief introduction to the time period and the sort of things we're dealing with, Castanet it's an ore ignatian site, so it's one of the earliest Upper Paleolithic occupations of Europe. So prior to this, there were Neanderthals living there, and these are the modern humans that have sort of moved in and replaced or possibly interbred with them. And what's really kind of interesting about it is this is the first time we see really a systematic production of art and adornments in the archaeology of Western Europe. So you can see here there's some variation with examples between beads and these little ivory figurines that seems like there's a new one in science about once a year. And then a really extensive sort of bone and antler and bone industry as well. So Castanet is located kind of in this, right next to this little town called Sergiac. And just as a little bit of context, the site of Montignac here is where the cave of Lascaux is, the very famous painted cave. And the actual site of Cro-Magnon, where the fossil name was given, is from right down here in Les Aziz. So we're right in sort of the heart of French Paleolithic archaeology. And the site itself is a part of a complex of 9 different sites of Paleolithic age, ranging from probably about 200,000 years ago up to about maybe 15. And Castanet is right down here at the bottom. Further complicating things, the site of Castanet is actually divided into 2 sections, one that was excavated primarily in the 1910s, 1920s in the north here, and then the south or main sector where we've been excavating Ore Ignatian age fire features for the last 4 years. So this is just another view of it, sort of a front-facing east view of the north section and the south section, and then this whole area in between that isn't excavated because this is about I think it's a 17-ton block of limestone sort of overlaying the layers. Hopefully if we get funding, we're going to go in there with some heavy machinery and get it out, but until that time it's kind of our giant witness section, I suppose. And this is just a 3D sort of view without the vegetation and things on it. So the artifacts we find at Castanet, again, a large variety of stone tool types, bone and antler tools as well. But what we're really well known for at Castanet is a rich sequence of beads and other kind of personal adornments. Pierced teeth, like down here, a tremendous density of beads in all sorts of production stages. So people are probably actually making these things there. They're not just coming in and losing their necklaces. And then a lot of other things that were kind of broken, and you can't really tell what the other end of this thing might have been. So the way that the site was formed, we're in a really kind of neat position at Castanet, where we have one single Ore Ignatian occupation with these fire features sitting directly on essentially bedrock, the bottom part of a former rock shelter. So it used to have a big lip like this that hung out, and people were sort of in here doing what they did. And then sometime probably about 30,000 years ago, maybe a little bit older, the roof collapsed. And then there are several different further collapses in a series of sort of sedimentation that took place above it. So we have everything sealed very, very well by giant limestone blocks. Again, it's quite complicated to get in there and excavate them, but it actually preserves things very, very well. This is just two views of the stratigraphy between an older view and a newer view. And what's really kind of interesting is in the past it was thought to have two distinct layers separated by a sterile section. But that actually isn't the case. It was a little bit of sleight of hand by the excavator to sort of bolster another argument he was making. That being said, the stratigraphy at Castanet, it's one occupation layer, but it's very, very complicated. So this is just at one given time at the end of 2008. Each different color is a sort of named stratigraphic unit. And I should note that these things are not stratigraphic in layer cake one on top of each other. A lot of it is sort of lateral variation, taphonomic influences, water flow, and then a lot of it is actually sort of probably human agency as well. So you can start to see right here that these guys, the sort of semicircular two here, are the edges of a fire feature, so obviously they're going to look a lot different than where people were not burning tremendous amounts of bone and wood. Like I said, we have a series of very nice fire features at Castanet. So when we're excavating, we have to be very, very careful with these. There are not a lot of Aurignacian age fires that have really been well preserved and well excavated in the last 50 years. So these are the main areas that we've been excavating are these three over here. And just as a bit of scale, the big lines here it's a meter grid, and the little ones are quarter square meters. While we excavate, we need to obviously record as much as we can about the artifacts, and it's a very, very dense site. So each of these points over here are piece provenience, so accurate three-dimensional coordinates we have for an object we found. So in about 20 centimeters of archaeological layer, we have nearly 20,000 objects that we've excavated. And these are only the ones that are large enough to sort of shoot in with the total station over here to give us a really, really accurate three-dimensional point on it. Smaller things we probably have in the neighborhood of 50 to 60,000 little tiny flakes of stone and little bits of burnt bone. But as I showed before with the complexity of the stratigraphy, with the complexity of the soils, we need to have a way of recording that and then keeping the data from those surfaces from year to year. Because obviously we don't do this all in 1 year, so we need to be able to go back later and say, okay, that area that we cleared out, well, we need to remember what it looked like. We need to remember what the surface of it looked like, and what the kind of morphology of the surface was as well. So what I've been involved in at Castanet is using GIS tools with the excavation data to sort of map and look at these sediment variation and artifact density variations in 3 dimensions. And I've been doing this with using topographic interpolation. So this is how topo maps are often made, is discrete points that are sort of interpolated into a surface. The math doesn't care if you're dealing with something that's on the scale of continents or something that's on the scale of 4 square meters. So I've actually been quite successful in getting very quickly nice 3-dimensional digital elevation models for each stratigraphic unit, and then being able to project those into 3D and sort of go back and double check what our excavators sort of thought. And I'm going to walk through this process just a little bit using the excavation of this witness section that we very quickly found out was overlaying all of our fire features. So we got permission in 2007 to move it, to take it down. And I'm using this as an example just because it's very tall and the layers are very vertical and very kind of obvious. So this way it actually sort of illustrates the process a little bit better. So we take a series of points with a total station. This is usually in the neighborhood of maybe 15 minutes per square meter at the absolute most. That's with our older total station. The newer model is much, much quicker. Then we run a simple interpolation on it. For any GIS geeks, I usually use a Krieg method just because it ties it a lot better to the points, and the variation that we have is quite extreme. You know, it's actually going up more than it is back. So we need an interpolation algorithm that can kind of deal with that well. Series of error checks, whether it be just the variance of the predictions or actually using control points to sort of double check it. And the nice thing is it's quick enough that I can go back, if we do this and we're missing a big area that looks really terrible, I can go back into the field and redo it quickly. And then the way that we were originally doing this in 2006, 2007, before I got offered a Gigapan unit and sort of trained in its use, was then taking a number of sort of individual photographs and then georeferencing those into the site grid. And from that, you can kind of build a mosaic that, it looks okay, but the resolution is quite different. The angle of the camera is quite different in various places. And really, the quality of the image is very contingent on the photographer. And I'm not a very good photographer, so you can see that I've got big exposure differences and all sorts of things that really didn't make it look all that pretty. But then again, since we've been using the Gigapan, we're quite easily able to go in and do the entire surface at one time, and then get that image into these databases as well. At Castanet, it's sort of an odd setup, so we had a little bit of difficulty trying to find what the best place to put this thing was. All the way from me taking my life in my hands and being on a 10, 15 centimeter wide lip, 8 meters up the cliff face, holding the thing out over it, which really did not keep it very steady at all, probably because I was shaking and scared, to sort of using an angled view on it. This way worked quite well, but we eventually managed to bite the bullet and buy a much nicer tripod, and we started doing them actually horizontally mounted like this. And it works quite well for lighter cameras. With the SLR here, you have to kind of assist it when it rotates just because it can't quite do it. I just put a little bit on here on the settings, but really it's all kind of contingent on the layer. But once we have these, what I usually do is I'll do one with a series of sort of marks on the surface like this that are points that I have recorded in the total station so I can go back and reference the image. And then a second one without those. So this is one from 2009 kind of showing the totality of where we were excavating. And then if I can get this to work, whoops. I also have, this is one from just this summer as we're coming down to the very, very bedrock base of the excavation. And we can pick out very, very interesting things quickly. And it goes fast enough in the small area that we can actually get a good time series going as well. So we have here just a soil detail all the way back out to sort of individual stone tools. This is displaying okay? Yeah. Into, these are some cervid teeth, some deer teeth that the whole mandible is underneath. It just hasn't been excavated yet. And you can see it actually sometimes is not good because you can see where people have not cleaned the layer very well and they haven't done particularly great excavating, like this place right here where somebody has, there's actually, well, it's not coming in too well, but there's a little plant shoot coming out right there, which is something we generally don't want in archaeological sites. So, oops. So once we have these things shot in, actually getting them into the site grid is a little bit of an issue as well, because obviously as the camera's sort of going outwards, it's going to be more distorted at the edges. So I usually overshoot what I want and then use a series, these points to actually tie it into our site grid. In the case of these Gigapans, I usually use a spline interpolation method just because I've got points all over the place and I've got topographic variability as well. So if I know a series of points, I can really kind of get it in there well. And it's been quite nice for the last several, for this summer, because we have the actual limits of each one of the quarter square meters marked, so I can actually just knock those right out, and they're thumbtacks. I don't have to mark things on constantly. And then I usually do, if I have marked points on the surface, I take another image at the exact same time, just repeat the same Gigapan without the points, and then I can tie those back together just by taking the referencing from one, sort of applying it to the other. And once we have these things sort of in the database, we can start projecting the points and the surfaces in 3D, generate little topo lines, because nobody but a GIS nerd really knows or can really follow that this white to light blue is some sort of elevation thing. And then get the actual photographs in 3D as well. And these turn out pretty well generally. This is the old one with sort of the handmade photo mosaic. But as we go on, we get some really neat things out of this. We have, from this summer, this is only, I think I have about 10. So these are 5 of the 10 images I have as we're excavating. And you can sort of see as things are coming out towards the base here and they're getting down towards bedrock. We can also use this to sort of record our stratigraphic units. So we've identified a unit, but now we can go back and actually say, well, what did that really look like? And even being able to get in on the grain size of the soils is really pretty cool. And then, of course, big impressive thing for when you have funding sources coming by the site and tourists is actually visualizing these things in 3D, which really or in fact, this is 2.5D because it's just draped over a surface. But it works really well. And let me just show, unfortunately, a lot of these things are a pain to try to show on the fly, so I've just recorded a series of movies kind of zooming around them. So this is that same image with another piece from the north over here put in. You can see those teeth are completely clear and sort of beautiful, right where they would be in 3 dimensions. We got our same, it's going to go in on the same stone tool over here. And then kind of circling around this sort of where the soil sample or the sediment detail was from earlier. Okay. That being, okay, at this point, I know my title says that I'm going to stay in France, but I'm going to just briefly jump over to a medieval cemetery in Ethiopia just because it falls in the category of too cool to not show off. This is at the site of Lalibela, which is a UNESCO World Heritage Site. It's these rock-cut churches that are sort of excavated down into the bedrock as one solid unit from sort of the 11th to 13th century. But the order of construction, the absolute dates are unknown. So that's what we were there to do, was to first create, this is just another fancy image, first go to do a series of topographic survey just to record where these things are in a really accurate plan, and then to also try to do a little bit of excavation into the dating and sort of the phasing, where they all constructed at one time or were they constructed sort of in separate lumps. This is the plan I came up with at the end of the season. But we also did a little bit of excavation at the cemetery site to the north of Lalibela, the churches of Lalibela. And we found, just from a farmer telling us that he pulled a skull out when he was plowing. We did 3 days of excavation there and uncovered 7 different graves. Extremely varied in number of individuals, in depth, in orientation. It's a really interesting site. This is just an example of one that had a series of grave goods in it and had, I think, 7 individuals in this sort of communal thing sealed by these big slabs. But we also found another one that was just one individual in a really shallow grave. And just as a trials of fieldwork, I have this red thing up here to remind me that even if you're missing big parts of your tripod, you can actually make do with things on hand in the middle of nowhere in Ethiopia. So I'd lost the socket. They forgot to bring the socket for me. So this is a cow scapula that I've drilled a hole in and then duct taped onto the tripod. So the equipment is pretty versatile in how you can actually use it. So let me show off the Gigapan of this guy. It's really pretty neat. You can get into the level of, I don't know if it's going to load well. Well, for some reason, the internet does not seem to be behaving for me. You can get into the level of looking at the fragmented bones. You can actually see the stuff on the inside, the spongy bone on the inside. But what's really quite neat about it is even with only doing this in an afternoon, I got enough topographic points to sort of generate a 3D model of it as well. And this, even very quickly done, really kind of shows what this thing looked like a lot better than just photographs can. And there's some errors, things like here where the interpolation is sort of missed where that thing was, because I didn't have points on it, and a couple of little things in the bone. But it really kind of shows well sort of how the guy was laying and sort of what records it, I think, better than it could be in sort of a two-dimensional way. Okay, so now I'm going to jump all the way back to France to talk about some stuff we started doing this summer with 3D scan data and trying to incorporate the Gigapans into that. And at this point, I just want to give a caveat that this is the first time I'd even seen a 3D scanner was this summer when, as the resident tech geek on our site, they showed up with one and said, here, learn how to use this. And while I'm quite good with technology, I'm quite a techno geek for a Paleolithic archaeologist, that's kind of like saying I'm the prettiest girl that didn't get asked to the prom. We don't tend to really deal with a lot of these things. So if I make a mistake in how I've done this, please yell at me later. But again, just to return to Castanet, this is the formation, and we're kind of dealing in this north section here, where the rockfall, the collapsed shelter, actually has engraved and painted surfaces that were formerly the ceiling that have fallen directly onto the archaeological layer. And we found these in 2007 when we were doing a small kind of trial excavation just to verify that the stratigraphy was the same in the northern section, that it correlated well between them. And we did this by sort of removing this big block that was in the profile. It was in the really old stratigraphic profile. And it's overlaying here, so you can see that this is the actual archaeological sediment below it, and it's sort of coming up in here as well. And as a scale, this is that giant block, and that's, she's probably about 6 feet tall, just right in there. So archaeology being a slow, careful process where you use the best tool for the job, there was no possible way we could get out of that thing out of there, so we're actually using a big drill and then splitting it into pieces, which it normally wouldn't be a problem if you then didn't realize that you'd broken in half some of the oldest artwork in Europe. So you can see here there's an engraving. Fortunately, the way that we did it was quite systematic, so there's nothing lost, it just happens to be split. So you can see that this is, we're not really sure what it is. It's been sort of interpreted as one of these vulval figurines or engravings. But I mean, we tend to call it the cherry, just because that's what it tends to look like to those of us that are not experts in Paleolithic art. But we ended up with quite a problem, which was one, knowing exactly where this thing had come from so we could begin to date it, and B, how are we going to refit the giant pieces of this block together. 4 minutes, okay. Because it weighs a ton. I mean, quite literally, probably close to a ton. With the negative, we got kind of lucky that it had fallen directly on the layer. And we were actually, this is before I had the Gigapan, this is just a regular photo, in doing a topographic study right there, right after we'd excavated it, we actually can pick out the negative of the engraving on the surface. So we know exactly where it came from, which is quite nice. But then we're left with this, and how to kind of deal with this, particularly how to preserve it and how to record it as best we can before we got permission to clean it. So like this, you can't really see much. This is just sitting in a barn. It's usually covered. We took the cover off. If you change the light sources a little bit, you can see the engraving pretty well. And then, so what I did this year was to go in and actually do, to do some Gigapans on it, which turned out, well, I don't know if this is going to work any better, to be honest. But you can see that, with manipulating the light, and I actually did several of these at night as well, so it does work quite well to sort of stationary a light source and try to get these things in darkness. But then, whoops, I keep hitting the wrong button. Let me see if I can actually zoom in. Yeah, so we can get some sort of nice detail of what, yeah, it's not really loading at all. Yeah. Well, that was going to be a big joke because that's a bat turd that had fallen onto it, so telling us that we need to keep things covered. But we actually got this 3D scanner this summer that was sort of abandoned in a laboratory that somebody just showed up with for us. And by scanning these blocks, we were actually able to refit the pieces back together in 3D and sort of recreate what the block would have actually looked like. And then through a tremendous series of trial and error, I kind of taught myself how to get the Gigapan images back on there. And it turned out pretty well. You can see the engraving. There's some that actually you can pick out by manipulating the light sources in 3D a lot better than you could by just looking at it. So there's probably something going on down here as well. And just what we can actually end up doing with this is just a little video of refitting the block back together. You can see these other possible engravings down here, the Gigapan on it. There's something right here too that is probably for suspending something from the ceiling. And we have a really nice sort of surface across it. I'm just going to skip these. And then with the imagery, actually, with the Gigapan actually in there, we have all of the detail that we would possibly want of everything adhering to the surface before we clean it, everything kind of there, ready to go. And what's really quite neat about it is, I'm just going to skip ahead because it's too slow, I think, is once we have this in this sort of system, once we have it in 3D like this, we can begin to put it back the way it would have looked on the surface of a ceiling, and actually see what it would look like if you were sitting down below it, which we could never do with a 1,000-pound block. So this is how it would have, this is sort of facing where the cliff would have been and kind of looking into the shelter. It would have been, well, the height is a little unknown, but it probably would have been about my height. And then I was looking up there, but we can manipulate the light and kind of play with how it would have looked at any given point as well. Okay, so just to conclude, for archaeological context, Gigapan is by no means limited to landscape panoramas or even things that are sort of facing you. Using them downwards is actually quite useful and works quite well. And then actually putting these things into 2.5 or 3D is really not that hard. For a GIS context, it's really, really easy because it's the same sort of tools that have been designed for putting satellite imagery on things, putting aerial photos onto things. The scanner data was a lot more complicated for me, but just using a number of kind of open source free visualization software packages, I was able to do it, but I'm sure a trained person could do it a lot more effectively. And the final product for us is really, what's been really, really great is that being able to do the time series is wonderful, but what's really wonderful for us is I work with a French team in Ethiopia and in France, so there's no other way we can actually trade data back and forth. So we have all of these things up online, and all of our experts throughout the world are kind of looking at things, particularly the block, analyzing these, looking for the traces, sort of figuring out what was going on there. We have it all in an easily accessible way. And again, just because archaeology is inherently a destructive process, we kind of destroy our site to learn about it. This is an absolutely wonderful way for us to record the absolute maximum of data so that 40 years down the line, we're not laughed at by our descendants. And yeah, I just put up a thing of funding acknowledgements, but otherwise, that's about it.